In section 3.6, we're going to continue working with solving equations, but we're going to start to see situations that are more complicated than the ones we've seen so far. So the first new thing we run into is right here in this first example. So far, every equation we've solved has had the variable on one side or the other. And maybe there's multiple terms of that variable, but they're all on one side. So here we have x terms showing up on both the left and right. And so what we need to do here is, as a first step, we need to get all of the variables on the same side, because ultimately we're trying to isolate our variable. So before you can isolate it, you got to at least have them all on the same side. And it really doesn't matter which side you move them to, but you should always look for ways to make less work on yourself. So if I moved 8x over to the right, I could do that, but then I would have to add 6 and then divide by whatever the coefficient of x is over here. So I would have 2 steps after moving 8x. If I move 5x to the other side, then I'll only have an x term on this side, and so the very last thing I'll have to do is apply the multiplication property of equality. So basically, moving 8 over will take 2 more steps after this, and moving 5 to the left will only take 1 more step. So I'm going to definitely choose moving 5 over to the left. Since 5x is positive, I will subtract 5x from both sides. And the more of these that you do, the more confident you'll get in determining what the easiest road to take is when you're deciding how to move your variable terms around. So of course I can divide by 3 on both sides. So my x is equal to -2. All right. So the extra complication that we ran into here was that variable terms appeared on both sides. So we got them on the same side, simplified, and then of course proceeded as we have before with solving that equation. Here we have that situation once again. 7x minus 6 equals 4 minus 2x. Now we have variables on both sides and constant terms on both sides. Okay, so in a situation like this, what we want to do is, like in the last example, we want to get variable terms on one side, but then we're always going to get the constant terms on the opposite side. So we want x's on one, or whatever variable you're using, on one side, constants on the other side. So I'm looking here. And again, it doesn't really matter whether you move 7x to the right or minus 2x to the left. You'll get the correct answer either way. But one rule of thumb that's nice to follow is, all other things being equal, if you can keep the coefficient on your x positive, that's just one less thing to think about, right? Rather than having to have a negative number on it. And so the way you can always ensure that will happen is if you move the smaller of the two coefficients. So you look at 7, you look at -2, which is smaller. Well, -2 is smaller than 7. And so what that means is you're going to move this one left. So we'll add 2x to both sides, and that will get all my x's on one side. And then we'll go ahead and add 6 to both sides to get all the constants on the other side. And of course we can finish a problem like this by dividing by 9. And again, this is an algebraic problem, so we want to keep our answer as an improper fraction. We do not want to turn it into a mixed number.